This meeting is being recorded.
For problem 7 in chapter 11, we are asked once again to identify reagents that could be used to accomplish transformation. So we'll take a look at 4 out of the 6 parts that are mentioned in question 11. So let's take a look at part A here, and we can determine that our starting material has 5 carbons, and then our product, 5, 6, 7, 8, has 8 carbons. So our synthesis must involve installation of 3 more carbon atoms. So in addition to this, the identity of the functional group also must be changed. So we went from a triple bond in our starting material to a cis double bond in our product. So we can use a retrosynthetic approach to determine what we need to do here. And you should note that if we're going from our starting material to this intermediate here, we've added on 1, 2, 3 carbons over here. So we could accomplish this by performing an alkylation, right? So we've added using sodium amide, and then our electrophile, we could use something like propyl iodide, and that would install this group over here to our starting material. And then at this point, we need to convert that triple bond to a cis double bond. And we can do that with hydrogenation using a poisoned catalyst, such as Lindlar's catalyst, and that would accomplish our desired product. Let's take a look at part B, and we'll start in the same fashion. So our starting material has 5 carbons, our product has 7, so we must add on 2 additional carbons. And we also, we do not have a change in functional group now, but we still need to make sure that we have the right product at the end. So what material can be used to make an alkyl halide, we might ask ourselves, because that could be used as an electrophile. So let's see here. So we could create this alkyl halide by first converting our alkyne to an alkene. We could use H2 and Lindlar's catalyst again to generate this alkene here. And then at this step, we could follow with an anti-Markovnikov addition of HBr on that pi bond. So that would give us this alkyl halide, and we can use our we can treat this rather with acetylide, and we could generate our desired product. So we would have this right here. Sodium is our counter ion, and this would generate our desired product. So let's take a look at part E now and see how we can accomplish this transformation. So we have a starting material with, let's see here, how many carbons? 1, 2, 3, 4. In our longest chain, our product has 1, 2, 3, 4, 5, 6. So somewhere we have to accomplish addition of 2 more carbon atoms. If we use retrosynthetic analysis, our alkyne target molecule begins with this disconnection of a carbon bond adjacent to the triple bond. So that would be right here. So let's see what materials we can use to accomplish these transformations. So in step 1, we see we can go to this intermediate product that has a relocation of that double bond. So we could do an addition reaction in a first step here using HBr, and it would have to be anti-Markovnikov. And then we would do an elimination that would utilize a more sterically hindered base, such as terbutoxide potassium, to generate this Hoffman product again down here, this intermediate. To go from that Hoffman intermediate to this alkyl halide shown next, we could again use HBr and do another anti-Markovnikov addition. So that's why our bromine is over here now. And at this point, we can then convert using sodium acetylide again, to our final product here with our 6-carbon chain length. For the last reaction that we'll look at in example F here, we go from an alcohol to an aldehyde functional group. So we've converted our functional group. The position remained the same though. So in the first part of this reaction, first we could go from or convert this from an alcohol to a tosylate and then perform an elimination reaction. So to go from an alcohol to a tosylate, that better leaving group, we could use tosyl chloride in pyridine, and then we want to end up with a less sterically hindered intermediate. So this is our Hoffman intermediate. Here we would have to use a sterically hindered base, such as something like terbutoxide potassium, and then we could perform ozonolysis here. So we haven't seen this recently, so we could use ozone and DMS, and we would accomplish this transformation to our aldehyde product.